Everyone, and welcome to Mr. Ahmed's Math 20 screencasts. Today we are starting up Chapter 3, which deals with surface area, volume, and capacity. So moving right on, we are starting off with surface area of prisms, so this is Chapter 3.1. And to be able to do this, you do need to become acquainted with the areas of the following shapes. For a rectangle, you just take your length and you multiply it by its width. To get the area. So one side times another to get the area of a rectangle. A square, since it has equal areas, since all of its sides are equal, to figure out the area of a square, you just need to take one side and multiply it by the other side. But since these are the same sides, s times s, for instance, would just become s squared. Okay, so that's why the area of a square is known as s squared, because it's just the same side multiplied by itself, and that therefore is just that side squared. For a parallelogram, to get the area of a parallelogram, you've got to take the base and you multiply it by the height. Make sure that your base and your height are perpendicular to one another. That means that there's a 90-degree angle between them. For a triangle, the area is the base of the triangle times the height of the triangle divided by 2. Or it could be the base of the triangle times the height of the triangle, and then multiplied by 1/2. So multiplying by 1/2 is the same thing as just dividing by 2. For a circle, the area is pi times r squared, where r is the radius of the circle. So from the middle of the circle to the outer edge of the circle, that is known as the radius. So if you were to take this radius and multiply it by itself, or square it, and then that value multiply it by pi, that would give you the area of the circle. And then finally, for a trapezoid, you've got to take the base, two sides of the trapezoid, so the base of the trapezoid and the top part of the trapezoid, so these two sides right here, you add them together, and then you multiply them by the height, which once again has to be perpendicular. Once you've done that, you then divide it by 2. So it's really just 1/2 times a plus b, so these two sides added together right here, and then times height to get the area. So moving right on to example 1, here it's asking us to calculate the area of each figure. For this rectangle right here, you are going to take the base and multiply it by the height, or just the length times the width. So that's 6.8. Oh, clear everything here. Okay, so that's 6.8 times 4.5. So that's 30.6 for the area of that rectangle. Now for the area of this triangle on the right hand side here, once again it is base times height divided by 2, or times 1/2. I personally prefer to just divide by 2. So base is 12.8 times height, so 7.8, and then divided by 2. It's 49.92 for that one. Okay. And then moving on to this parallelogram, once again it is the base times the height, and as we can see here, the height is indeed perpendicular to the base, so that will work out just fine. So 3.1 is the base times 2.1 is the height. So that gives you 6.51 for that one. Okay, so that's kind of what your workbook shows you. At this point, you can pause the video and get to work on the questions on page 127. So the Build Your Skills questions that start up on page 127. Okay, so moving on to example 2. Find the area of the following figure. There is no formula to find the area of this specific shape, so what you're going to have to do is you're actually going to have to divide this area, or this shape, down into areas that you can figure out. So for example, for this one, I would probably split this into 3 shapes. Here, my first shape being, if I were to draw a line right down here, where my cursor is pointing, I would now have a triangle like this, and then I would draw my second line here, like this, And that way I would have a rectangle here and a rectangle here. So that would be the way that I would do it. Now to get the area of this triangle right here, okay, so to get the area of this triangle right here, you do need its base. Remember that the area of a triangle is base times height divided by 2. So this base right here would be your 6.8 centimeters plus your 3.1 centimeters. So again, if this is 3.1 centimeters and then this is 6.8 centimeters, the sum of these two would actually give you the total base right here. So from this point up here down to this point right here. So doing that, 6.8 plus 3.1 gives me a base of 9.9 for this triangle right here. Okay, so that's the base. Here's my height. It's 12.6, and we know that for the area of a triangle, you're taking the base, you're multiplying it by the height, and then you're dividing by 2. So my base, which is 9.9, times height, which is 12.6, and then dividing that by 2. So that gives me an area of 62.37 for my triangle. Okay. Now here, remember that we had split this into a rectangle like this by drawing a line from here to here. Well, the width of the triangle or the rectangle is 6.2 centimeters, and its height is 3.1 plus 6.8, which we had said was 9.9. So what you're going to do is you're going to go 9.9, which is the height of this rectangle, times its width, which is 6.2. So times 6.2. So this is the area of your rectangle. And then finally, the area of this right here. We do have its height. We don't have its width, but if we know that from here to here is 13.4, and that from here to here is 6.2, we can definitely figure this out by subtracting. So we would go 13.4, which is the length from here to here, and then subtract 6.2 minus 6.2. That gives you 7.2, so that would be the width here, 7.2. So 7.2 times 6.8 to get 48.96. So we figured out the individual areas of each one of these shapes, and then finally what's left to do is to just add the areas of those together. And that's what your workbook shows, or maybe not. Your workbook does split it up into a different way. But just know that if they want to split it up that way, that's just fine. So for our purposes, we're going to go back and we're going to add the area of this triangle. So that's what I had here. So that's 62.37. And then I'm adding that to the area of what we had found here, which was 9.9 times 6.2. So that's 61.38. And we are also adding it to this width times this height, so this little rectangle right here, which was 7.2 times 6.8. So that's 48.96, so we add 48. Oh, looks like my... Okay, there. So that should give us 172.71. So 62.37 plus 61.38 plus 48.96. That gives us 172.71. So there you go. The total area is 172.71. So again, there are different ways of doing this. As you can see, your workbook decided to just split it up in a different way. It really is up to you. Yeah, it really is just up to you how you want to split it up. Okay. So there you go. Actually, here's an alternative solution. That's kind of what we did right here. So your workbook does show our solution. So at this point, you can pause the video and get to work on the questions on page 131. The Build Your Skills questions on page 131. So starting on that page. Okay. So we are going to move on. We don't need to do this part right here, so we're going to move right over it. And we're going to go right on to page 134, which deals with working with nets. Nets are really just 3D shapes that you would take and you would unfold. Okay, so you would just take those shapes and you would unfold them into something like this. So if this is your 3D shape up here, and you were to unfold it, so for example, you'd say like maybe this space right here would be where, like your starting point, and then you unfold everything around that or something like that. So here's what you would end up getting. So that's what a net is. Okay, so at this point you can pause the video and try out the following questions, the Build Your Skills questions on page 135. And again, it's asking you to draw the nets, so you're really just taking these 3D shapes and then splitting them down into, or breaking them down, or unfolding them down. There we go. You're unfolding them down into things that look like this. This is what we call a net. Okay. Okay, moving on to example 5. Find the surface area of the right rectangular prism given below. To find the total surface area of this prism, what you need to do is you actually do need to figure out the area of each one of these individual sides, and then add it all together. So they decide to draw out a net of this to figure out the area, and that's not absolutely necessary. If you don't want to draw out a net to figure out the area of your prism, you don't have to, as long as you've got kind of a good visual 3D perception, as long as you can kind of take this image and almost move it around in your brain and be able to look at its sides, then you should be fine, and you shouldn't really need to draw out the net. But if you're not really good at working with 3D objects, then maybe drawing the net would be the first step for you. Otherwise, what you would do, first of all, is you'd figure out the area of one of these sides. I'm going to start with figuring out the area of this front side right here, or this front, I'm not going to say square, but rectangle. So it's got a base of 4.6, it's got a height of 3.8, so 4.6 times 3.8 to get the area of that individual one. So that gives me 17.48 as being the area of this individual rectangle. Well, you'll also notice that you've actually got this front side, but you do also have a back side as well. So this rectangle right here with an area of 17.48 is actually happens twice. So in the front here, as well as on the back of your rectangle. You can't see it, it's in the back, but you also get that side repeating twice. So since it repeats twice, it would be safe to just take that 17.48 and multiply it by 2 to get the total area of just those two sides, which is 34.96. Now, the next step, once you've figured out the front and back, you can figure out the area of the sides. So let's go for this side right here, and the side that's hidden on the left-hand side. So this side right here, this rectangle, has a base of 1.9 and a height of 3.8. So 1.9 times 3.8. And you end up getting 7.22, but we know that this side repeats twice, because you've got one on this side here. So at that point you multiply by 2 to get the total area of those two sides, which is 14.44. Now once you've done that, so we've done the front and the back, we've done the sides, now all that's left to do is the top and bottom. So doing that, this length right here is 4.6, this length right here is 1.9. So to figure out the area, you go 4.6 times 1.9. That gives you 8.74. And of course there's two of these sides, there's the top and the bottom. So you would take that 8.74 and you'd multiply by 2. That gives you 17.48. Okay, so we had 34.96 as being the area of the front and back. So 34.96. We had 14.44 as being the area of the sides, and we had 17.48 as being the area of the top and bottom. So what you would have to do is you would have to take all of those areas and add them up together as I just did, and you get 66.88, or probably 66.9 is what they'll tell you is the answer. So there you go, 66.9, and that's what your workbook does show. Okay. Okay. At this point, you can pause the video and try out questions, the Build Your Skills questions on page 138 of your workbook. Okay, so just give me one second. I'm suffering from a cold, so please don't mind the following. Hopefully I'll be over this cold for the following screencasts. But moving right on to example 6, so find the surface area of this figure. Now this one here is a little more challenging in that it involves a lot more surfaces than what we've seen so far. And you know, if you wanted to take this and draw a net of it and split it down or break it down into its net, you can do that. Otherwise, you can go and figure out the individual surface areas of each one of these and then add that all up together. So that's probably what we'll do here. So I'm just trying to, how do we start this one? Well, we've got this square right, or not square, but this shape right here, and then this shape right here. And the fact of the matter is that this length right here and then this length right here, those are both 78 centimeters. Okay, and then they both have a width of 27. So if I was to actually just take 78 centimeters times 27 centimeters, that would actually give me the combined area of both of these, right? Because again, they are almost right side by side, right? So this length right here and then this length right here, those are both 78. And it's almost like if I was to take a top, if you were to take a look at this from the top, then you would notice that these two side by side just look like one big gigantic rectangle. Okay, so that's what we're going to do. We're going to figure out the area of that big gigantic rectangle. So we've got a length of 78, or sorry, I'll just erase this history. Okay, so you've got a length of 78, and then you've got a width of 27. Okay, so that's 2,106, and that would just be for this area right here and this area right here. Now we would probably want to figure out the area of this and then this as well. And again, if I was to take a look at this from the side, from this side over here, you'd actually notice that this guy, or this side, looks like it's right beside this side as well. Okay, so you'd actually get a big gigantic rectangle with this side and this side. Okay, so I know that their combined heights is 55 centimeters, and I know that they both have the same width, which is 27 centimeters. So I'm actually going to go and figure out what is the combined area of these two sides. Okay, so 55 centimeters times 27 centimeters. So that gives us 1,485 being the combined area of this side and that side. So far all we've got is we've got these two sides and we've got the area of these two sides. So we've got all of this right here. Now we've got to figure out the area of this side here, the back side, the left side, and the bottom. Okay, so the area of the front side right here, looking at this, it's 55 centimeters, and then this height right here is 30 centimeters. So if this is 55 centimeters, and then this is 30 centimeters, then you could figure out the height of this part right here. So, because what I'm going to do is I'm just going to take this and break it down into, make a line right here, and that way I've got one rectangle here, and then one rectangle here. Okay, so if I were to draw a line right here, I would need to figure out the height of this part right here. And if all of this is 55 centimeters and then this is 30 centimeters, then that means that this little part from this point down to just here has a length of 25 centimeters. So this is 25 centimeters right here. And now the next step is to figure out the width of this part right here. And you are provided with this as being 78 centimeters. And you are provided with this part from here to here as being 45 centimeters. So if from this point to this point is 45 centimeters, and we want to figure out what this line is right here, and we also know that from the entire length is 78 centimeters, then you would just go 78 centimeters minus 45 centimeters to get the length of this right here, which would just be 23 centimeters. Okay. Sorry, did I say 23? I meant 33 centimeters. So that would just be 33 centimeters from here to here. Okay. So doing that, we have this width right here, which is 33 centimeters long. We have this height, which we had figured out was 25 centimeters long, so times 25. That gives us 825 centimeters for this part right here. Now what's left over is to take this area and figure this area out, and then add it up to this, and then multiply it by 2 because you've got another of that same side in the back. Okay, so let's we have to figure out this area. We know that this is 78 centimeters wide. We know it's 30 centimeters high. So this is 30 centimeters high right here. So 78 times 30 to get the area of that right here. So doing that, 78 times 30 gives you 2,340. Which we would then add to our little 825. That was this one right here. So plus 825, and then that gives us 3,165, which is the total surface area of this L shape right here. We would actually take that 3,165 and then just multiply it by 2, because we do have another L shape in the back as well. So 3,165 times 2, that gives us 6,330. So the combined L shapes right here for the front and the back would have an area of 6,330. Okay, so we have done the front and the back, we did the top, so all that's left right now is the side right here and the bottom. Now the bottom is just straight, it's pretty straightforward, it's just 78 times 27. So 78 times 27, that gives us 2,106. And the side right here is just 55 times 27, because if this is 27 right here, then we know that this length from here to that invisible point that you can't see right there, that would also be 27 centimeters as well. So you would take the height, 55, excuse me, so you take 55 centimeters and multiply it by the width of 27 centimeters. So 55 times 27, and then that gives us 1,485. Sorry. So now all that's left to do is just add all those areas that we jotted down throughout this entire example. So here they are. I was jotting these down as I was figuring them out. So 2,106 plus 1,485 plus 6,330 plus 2,106 and plus 1,485. So that gave me a total area of 13,512. So yeah, that's the total surface area, 13,512. And as they show you, they decided to split it up into different areas, and that's exactly what you're supposed to do. You're supposed to take this shape, break it down into its areas, figure out each one of these areas individually, and then add them all up together at the very end. So that would have given you 13,512 centimeters squared. Now, here's your alternative solution, and that's the solution that we did. It tells you that if you look carefully at the diagram, you'll discover that you don't need to calculate the area of each individual surface. And they're talking about the shaded portions are equal in area to the left side of the figure. So they're really just saying, they're saying exactly what I said. This shaded portion and this shaded portion would actually just make up like a rectangle. And then this shaded portion here and this shaded portion here would also make up just a rectangle together. Okay. So at this point, you can pause the video and try out the Build Your Skills questions on page 142. If you'll excuse me, once again, I am suffering from a cold, so please forgive the following. Okay, and then finally moving on right to example 7. Kareem's been hired to paint the walls and ceiling of a living room in a house. They give you the dimensions of the living room. There's one window that is 10.5 feet, blah, 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 two windows that are 3.5 feet by 2.5 feet, and then two doors that are 2.5 feet by 8 feet. What surface area must he paint? So what you're going to have to do, you're going to have to draw this out, and it tells you that he's been hired to paint the walls and the ceiling of the living room. So you're going to have to figure out the surface area of what he has to paint. So that's 4 walls and 1 ceiling. So be careful to not include the floor because he's not painting the floor. So he's painting the walls and then 1 ceiling. And once you figure out that combined area, then you would subtract the areas that he doesn't paint. So there's a 1 window that has 10.5 feet by 6 feet. So you subtract that. 2 windows that are 3.5 feet by 2.5 feet. And then 2 doors that are 2.5 feet by 8 feet. So you just got to make sure that you are subtracting these little parts that you don't need. Okay, so it does show you here, so it tells you the ceiling is 22.5 feet by 13.5 feet, so they figure out the area of the ceiling. There are 2 walls that have the following dimensions. They figure out the area of those 2 walls. The other 2 walls have the following dimensions right here, so they figure out the area of those 2 walls, well, of 1 wall, actually. So this is the area of 1 wall here and 1 wall here. And then calculate the total surface area. So here's your ceiling. Here's the area of 1 wall multiplied by 2, because there are 2 walls that have those exact dimensions. And then the area of that other wall multiplied by 2, because there's 2 other walls that have those dimensions. So this is what he would normally have to paint, this value right here, 915.75. That's what he would normally have to paint if there weren't any windows or doors in this room. Except since there is a window that's 10.5 feet by 6 feet, they figure out its total area. And then they would subtract it from 915. So actually what your workbook's doing right now is they're just figuring out all the parts they're going to subtract first. So 2 windows are 3.5 feet by 2.5 feet. So here's the area of one of those windows. And then there's 2 doors, 2.5 feet by 8 feet. Here's the area of one of those doors. So they're going to take this total surface area, subtract 63, subtract 8.75 times 2, and subtract 20 square feet times 2. And I'm saying times 2 because there's 2 windows that have those dimensions. There's 2 doors that have those dimensions. Okay, so that's what they do. Well, they actually figure out the total area that they won't have to, that Kareem won't have to paint, which is 120.5 square feet, by adding all those areas together, and then subtracting that 120.5 square feet from 915.75. So that's how much he needs to paint. Now B was asking, it told you 1 gallon of paint covers approximately 255 square feet. How many gallons will you have to buy? So you could actually set up your proportions there. If 1 gallon covers 255 square feet, he's got this many square feet, then you could just go that many square feet, 795.25 square feet, divided by 255 to get 3.1 gallons. And if you're buying this by the gallon, then you can't really actually buy 0.1 of a gallon. Like, you see how the answer is 3.1? You can't buy 0.1 of a gallon, so that would force you to buy 4 gallons of paint. So make sure that you're not just rounding. You're not rounding 3.1 down to 3, because if you were to round 3.1 down to 3, then actually this Kareem fellow would just not have enough gallons of paint. And then finally they tell you that if the paint costs $55.40 per gallon and he wants to make a profit of that much, how much should he charge? So we know that he has to buy 4 gallons. So I'm just going to clear this history. If he has to buy 4 gallons and each individual gallon costs $55.40, that means that the amount of money that those 4 gallons would cost is $221.6. But he also wants to make a profit of $225. So he'd add $225 and that means that he would have to charge $446.60 to cover the price of the paint, and also to cover, well, to make sure that he gets paid $225 for his work, for the labor. And that's what they do down here at 446. So at this point, you can pause the video. You can get to work on your Build Your Skills questions. However, you also have your practice your new skills questions right after that as well. So that is the end of chapter 3.1, and please tune in for chapter 3.2.